Hello, I'm going to present a solution, or shall we say proof, to this exercise for my differential geometry class. I presented this in class yesterday, and I wanted to record it as well. So we've got gamma of t, v of t, and a of t, denoting the position, velocity, and acceleration vectors of a given curve, respectively. Prove that the rate of change of the speed, norm of v of t, is given by the derivative of speed equals plus or minus the projection of acceleration on velocity. Okay. So we have the left-hand side equals d dt of v of t. We know that the norm of v of t is v transpose v to the 1/2. And that is just 1/2 v transpose v to the negative 1/2. And then we do the derivative of the inner part, v transpose v, and that we use the product rule for inner products, which says that the derivative of that is v prime transpose v plus v transpose v prime. Inner product is commutative, so this is just 2 v transpose v prime. Now we have that cancels, but v prime is acceleration, so that equals v transpose a over v transpose v to the 1/2, and that equals v transpose a over the norm of v. Now the right-hand side here, the projection of a onto v the plus or minus the norm of the projection of a onto v, which is really a really neat topic in itself. I love projections, so I'll make a little graphic here to consider. Let's say this is v and this is a, two vectors. The projection of a onto v is just where on v does a, if we shot like a projection down, where does it meet at a 90-degree angle? This is a scalar multiple of v, and we call it the projection of a onto v. It's a vector. Oh, it's so neat. There's a lot there. So let's say that, let's call plus or minus lambda the projection of a onto v. And we know that that is A transpose V over V transpose V in the direction of V. I'm sorry. We're saying plus or minus lambda is the absolute value of this. So that is to say that lambda times the unit vector in the direction of V equals the projection of A onto V, which is this this cute little thing here. So we can move. We're going to solve for lambda, and we can move the norm of V over. And I'm just going to say norm of V as V transpose V to the 1/2. And so we've got V transpose V to the 1/2, and then we also have V transpose V in the denominator to the 1. So that's 1/2 minus 1 is negative 1/2, which means that we can put V transpose V in the denominator to the 1/2. And this implies that lambda equals A transpose V over V transpose V to the 1/2. And that equals A transpose V over the norm of V. And since inner product is commutative, I can say that the left-hand side equals A transpose V over the norm of V, and now we see that that those two are equal, and that indeed the derivative of the absolute value of velocity equals plus or minus the absolute value of the projection of acceleration onto velocity. How cool is that?